Unit 3 is all about Boolean expressions, if statements, if else statements, if else if statements. Some of you doing your quarter project probably realized that there would have been a good need to be able to make a decision and put that in your program, and some of you actually did self-learn how to do this. So today we're going to focus on different types of conditional statements. All right, so first let's talk about what a Boolean is. A Boolean is a logical type, it's a primitive type, and it only has one of two possible values, true or false. Now, because it is a primitive type, you can create a Boolean variable. You can pass a Boolean value to a method as a parameter. When you write a method, you can return a Boolean value. And then you can basically call a method that returns a Boolean and then use that as part of a test of a condition. And so these statements are either true or false. There is no in between. So for example, here, if age is 22, and my minor is going to get a Boolean answer based on whether age is less than 21, you're going to substitute that value and you're going to test, is it true that 22 is less than 21? And the answer is no, that's not true. That's a false statement. And so that false value will be assigned to the variable minor. So that's the result of an expression. You could also create a variable that is assigned straight away the value true or false. Notice you don't put it inside quotation marks. It's not a string. In fact, when you type the word true without quotations, or when you type the word false, you'll notice in your IDE, your programming environment, you'll notice it changes colors, and that's because it does have a very special meaning. And then here you can also assume, like for example here, there's a method called isPrime, and let's pretend like it returns whether or not the parameter is prime. So if I pass it this number, it's going to return true or false. And to be honest, I have no idea. It might be prime, it might be false. I'm not sure, but it might be. So anyway, you pass it as a parameter to a method. That method will possibly send you back a true or false result. Because I'm assigning it to a Boolean variable, I'm assuming it does. So lots of different ways you can use it. Why it's important is because you can test some logical statements and use those results later, or you can use it immediately in that time. So you can write methods that do complex tests. It allows you to make your code more readable. You can take the result and you can pass it as a parameter, or you can return the value. So there's lots of different things. So let's look here. So next time we're going to learn more about what this symbol means, but for some of you, you might remember that this means and for something to be true in an and statement, both conditions have to be true. All right, so here, age is 21, height is 88, salary is 100,000. So good age is going to be assigned true or false depending on if this statement is true or false. So age is greater than or equal to 12. Well, age is 21, and 21 is greater than or equal to 12, so that's true. And then age is less than 29, so here age is still 21. Is it true that 21 is less than 29? Yeah, that's also true. And next time, in our next lecture, you're going to learn that and means if both are true, your result is true, so that's why it's there. All right, what about good height? Height is 88. So is it true that 88 is greater than or equal to 78? Yeah, that's true. Is it true that height is less than 84? Is it true that 88 is less than 84? No, that's not true. That's false. And because both of these are not both true, that would be evaluated to false, so good height would be false. What about rich? Well, I take my salary and I substitute it in. So remember, even though I didn't put a decimal when I assigned it to salary, because it's stored in a double, it does have a decimal. So is this greater than or equal to that? And the answer is true. So relational expressions, evaluate how you would expect them to evaluate. They just might look a little bit different than how you're used to in math. To check equality, we use two equal signs. One equals changes variables. 2 equals checks equality. So is it true that 1 plus 2 is equal to, all right, is equal to. Is it true that 1 plus 1 is equal to 2? Yes, that's true. Does not equal, in math class, you're used to seeing this. We use the exclamation point in front of an equal sign. So is it true that 3.2 is not equal to 2.5? Yeah, that's true. They're not equal. And then less than works how you expect it to work. 10 less than 5, that's a false statement. Greater than works as you would expect it to. 10 greater than 5 is true. Less than or equal to. In math class, you're used to writing this. Here you just write a less than and then an equal to. So is it true that this is less than or equal to 100? No, that's not true, etc. Okay? So here, let's go through these. So what you have to do is you have to substitute. 2 is equal to 3. Those aren't equal, so it'd be false. Here, 2 is not equal to 3. That's true, they're not equal. Here, 2 plus 4 times 3. Remember order of operations. 12 plus 2 is 14. Is 14 less than or equal to 15? Yep. Here, x is 2. Is 2 greater than 5? Nope. And is 3 greater than or equal to 3? Yep. All right, so it's just true or false. Is that a true or false evaluation? All right, yes or no? So we can use these Boolean expressions in something called an if statement. And so in an if statement, you're basically saying, I only want this block of code, these lines of statements to occur if something is true. If it's true, do it. If it's not true, skip over it and pick up after the block. So only when something is true in an if statement are you going to do the lines of code in between these braces. Now, in the absence of braces, you only are allowed to have one statement associated with the if. But that's bad form to put an if statement without braces because it can get a little confusing. Because in other programming languages, indentation is significant, like in Python, but in Java, indentation means nothing. So it's good habit, no matter if you have one statement or 100 statements inside your if block, use curly braces. So like here, if my GPA is greater than 2.0, my application is going to be accepted. All right, well, my GPA is 2.1, so I have to substitute. Is 2.1 greater than or equal to 2.0? The answer is yes, so application is accepted. All right, here, my GPA is 1.9. Is that greater than or equal to 2.0? The answer is no. So not only is my application not accepted, but I'm not going to get any output because there's nothing for me to do after that. Now, in an if statement, you only do something when a condition is true. And an if else, it's like an either or. Either you do this or you do that. You do this when your condition is true. You do that when your condition is false. Also, just like before, in the absence of braces, you can only have one statement attached to an if and one statement attached to an else. You will get a compiler error if you have multiple statements before your else without curly braces. All right, so just be mindful that these I expect to see every time I have an if written, or you write an if every time you write an else. All right, anyway, so either I do this or I do that, one or the other. So here, I'm either going to be accepted to Mars University or my application is denied. So if my GPA is 3.0, this is true, so I do this. So this happens when my condition is true. This happens when my condition is false. I'm only doing one or the other. So I got into Mars University. Yay! Even though that's kind of a low GPA, but gotta work hard at Mars University. All right, so again, this happens when my condition is true. This happens when my condition is false. So if my GPA is 1.0, that's not greater than 2.0, so I don't get into Mars University. My application is denied. Be careful though. An if statement, sometimes you want to have an if statement followed by an if statement, but if you look here, it's going to, let's say, enter a percentage, and it's supposed to say what your grade is. But let's say my percentage is a 99. All right, let's say my percentage is 99. So these are basically 1, 2, 3, 4, 5 different things. So I come here. Is my percentage greater than or equal to 90? Yep, I got an A. But this is a separate problem. Is my percentage greater than or equal to 80? Yep, I got a B. Is my percentage greater than or equal to 70? Yep, so I got a C. Is my percentage greater than or equal to 60? Yep, so I got a D. Is it less than 60? No. So it's going to end up displaying all of those, which is not what it's intended probably. Okay, so what you have to do is you have to basically make it so that way you have other choices. And the way we do that is through nested if statements. If this is true, you do that. Otherwise, if this is true, you do that. Otherwise, if this is true, you do that. So to fix this code, had I basically said these are your different choices, and then here I could have just said this because I didn't need any more. Either I got above a 90 and I got an A, else if I got above an 80. Well, the difference between this and the previous way it was written is here, I already made a decision. I'm not going to keep checking. As soon as you make a decision and an if else, you're done making a decision, you can continue on. So let's look at here, X is 10. Either I do this, or I do this, or I do this. So I do this first thing when X is greater than 0. I do the second one when X is less than 0. And if X isn't greater than 0 or less than 0, I just do that. All right, so X is 10, so is 10 greater than 0? Yep. So I do this and I'm done. I'm not going to keep checking because I'm only doing this, this, or this. It's a decision between 3 things in which you're only doing one thing. All right, what about when X is 0? So I'm either doing this, this, or this. I'm not doing all 3. So I come here. Is 0 greater than 0? Nope. Is 0 less than 0? Nope. So I do this. I don't have to test it anymore. It just says, fine, that's the default thing you're going to do. Okay? So if something ends with an else, you're always going to do something. Like here, I either did this, this, or this. I only took one path. And I always did one thing and only one thing. But if I end with an if, it's possible you do nothing. All right, like here, if I get first place or second place or third place, I do something. But if I don't get first place or second place or third place, there is no default else. So I either do something for first, second, or third, or I do nothing. So here, if my place is 2, I come here. Is 2 equal to 1? Nope. Is 2 equal to 2? Yep. Silver medal, I don't need to keep checking. Whereas if I have 6th place, I'm going to test, is 6 equal to 1? Nope. Is 6 equal to 2? Nope. Is 6 equal to 3? Nope. Well, I don't have anything else, so I'm not going to have any output. Okay, so it's possible that you have if, else. That's when you are doing something under every circumstance and you're doing exactly one thing. If you do if, else if, that means that you want to have different choices, but it's possible to do nothing. If you have an if, followed by an if, followed by an if, these are basically like 3 different tests. I can check it, what day of the week it is. I can check the temperature outside. I can check what time the movie is, right? I don't know. Okay, so these are checking 3 independent things. And it could be possible that 0 conditions become true, that 1 condition is true, that 2 condition is true, that all of them are true, etc. And so you would do the statements associated with that. So let's say I want to figure out if a user is in the lower, middle, or upper class based on income. Well, in this case, they're only going to fit into one category, and everyone is going to fit into a category. So you would use an if, else, if, else. If I wanted to see if someone made the dean's list or the honor roll, and that's all I cared about, it is possible that someone made nothing. And so I would want to narrow it down to be an if, else, if. I don't want to say anything to them if they didn't make the dean's list or honor roll. So here I am narrowing it down so that way not everyone gets a message. Only people who make the dean's list get a message. Only people who get honor roll get a message. Everyone else gets nothing. Let's see if I wanted numbers divisible by 2, 3, and or 5. Well, these are basically 3 separate problems. Is a number divisible by 2? Yes or no. Is a number divisible by 3? Yes or no. Is a number divisible by 5? Yes or no. Now, if I had said if a number is divisible by 2, 3, and 5, it would change my thing. But here, if I just want to see which ones they are, these would be independent if statements. And if I computed a grade and everyone falls into A, B, C, D, or F, then I would have an if for A, else if for B, else if for C, else if for D. And then by default, everyone would fall into F if they haven't made a category. One mistake students want to make is they want to put this little if at the end, but that doesn't really need to happen. If you didn't make an A, B, C, or D, that means you made an F. I don't need to check it at that point. Okay? Now, as we get into writing our own statements, just some things that need to be considered. If this returns a Boolean value, true or false, there's no reason to check if it's true or false because it's going to be the value that you need it to be. So this is how I want you to write stuff that returns a Boolean. Don't do that. It's not technically incorrect, but remember there's Java rules and there's Miss Gilroy rules. If this is already a Boolean value, you don't need to compare it against Boolean values. Same idea here. If this returns true or false, you don't need to check if it's equal to true or false because it is already true or false. Here you just have to negate it. If you're expecting it to be false, you just say not whatever it is, okay? And because it would take your false value, make it true, which would make your condition true. We'll see that more as we write, okay? Also, you might have a condition that gets pretty lengthy. Instead of doing something like this, you can make it a little cleaner by doing that expression and assigning it to a variable and just putting that Boolean variable in there. Okay. So we'll see more of those like as we get to it. Also, in here, technically we didn't need to write an if-else statement. This was already true or false. So if it was true, return true, else return false. We could have technically just said return whatever the answer was, and if it was true or false. And as we get more into writing code, you'll see that here we technically don't need to assign it to a variable. If all I'm doing is returning the answer, I could just do the expression, and that would be. So these are just different levels of like becoming more efficient with your code, which we'll learn as we go, okay? All right, so here's some optional labs if you want to try them out. But otherwise, it's good to practice tracing and good to practice writing them on your own, all right?